This video is intended to help you possibly improve your skills and your grade of the Year 9 Plate Tectonics assessment. We start off question 1, very low level command word, identify and applying our knowledge to the structure of the Earth. It tells us that that's the crust, that's the outer core, so you just got to fill in B and D. B is the mantle and D is the inner core, so that's maxed out at a level 4. On to 2, maximum level 5 question here. So the question tells us that conservative plate margin is at Z. We can see that there. You've got to identify X and Y. So we look at the key here. We can see that that's the line for the actual boundary or margin. And if we look at the arrows, we can see they're moving apart. And we've got a major earthquake and volcanic zone. And the only type of plate boundary where they're moving apart is constructive. So constructive at X. Y, well, the plates are moving towards each other. And that is indeed a destructive plate boundary. There's only destructive or collision it could be, but it's actually a destructive plate boundary because it's actually on the edge of the Pacific Ring of Fire, which has volcanic activity. So if you got those two right, level 5. Identify the type of boundary then shown in the diagram below. So we identify, we're looking at it, we're working this out. We can see the arrows going on this plate here, going underneath this plate, and it is indeed a destructive plate boundary. And you've got to add then labels for the different parts of the diagram. So oceanic plates is this one here, and we can see the oceanic plate, which is denser, which is subducting underneath the continental plates. That is the continental plate there. Subduction zone is here. That's where the oceanic crust is being subducted or going underneath the continental crust. The ocean trench is here. We can see that where it goes underneath, you can see that V shape, and that's where ocean trenches form, such as like the Mariana Trench. And then you've got the volcano form, where you've got your volcanic activity here. So there's your volcano form. Identify the type of volcano shown in the diagram below. So this is, we've only studied 2 types, shield and composite, and it is indeed a composite. Composite, a word broken down into components, and we can see here that this has actually got layers or different components. So then you've got to identify the features. So A is layers of ash and lava. B is a secondary vent. C is the crater, and D is the magma chamber. Describe the shape of this volcano and explain why it has this shape. So let's take a really clear structured approach for your examiner. Describe the shape. The shape is quite with steep-sided or steep-sided flanks and fairly triangular in shape. Why? Well, this is mainly because the lava has a high viscosity. It's very sticky. It actually has a high silica content. So when it comes out, and it's fairly sticky and it runs down the sides of the volcano, when it actually cools, then it creates this steep-sided volcano, rather than the other type, the shield, which is more of a runny type of lava, a lower viscosity, and that can run quicker and spread over a wider area, creating the volcano, which is more like a shield. Okay, 6, identify the type of plate boundaries shown in the map below. Well, we can see here the plates moving side by side in the arrows. We can see other fault lines coming off it as well. It is indeed a conservative boundary, also known as a transform boundary. The conservative's fine. Our American friends, they tend to call it transform. Explain why earthquakes occur on the type of boundary shown in figure 5. So this is where we need to explain using our step-by-step processes, a very logical, clear, clearly structured answer. Step-by-step how it occurs. It's how we approach our physical geography. Okay, so step 1. You don't need to write step 1, but this is how you got to think it in your mind. 1. 2 continental plates are moving side by sides. See this section here, and you can see that section there. As the plates collide, there is a buildup of pressure and friction occurs as the plates are sticking against each other. Eventually, due to a continued buildup of pressure, there could be a slippage in the plates, and when that slippage occurs, a vast amount of seismic energy is released, and this can create a violent earthquake. And that will do, and be fine. Question 8. Figure 6 shows the Transamerica building in San Francisco. Name 3 design features of buildings that help to reduce the loss of life. So it says 3 design features of buildings, not just this one here. You could, of course, pick out that the Transamerica in San Francisco is famous because it has a wide base, and therefore that creates a more stable building, which is less likely to collapse during an earthquake. Other features of buildings you could have are deep rubber shock absorbers in the base or underneath the ground. You could refer to counterweights on top of the building. So when the building sways, the counterweight goes one way and then the building goes the other. And this prevents it from collapsing. You could have cross bracings on the windows, which adds stability, and also linked to like shutters on the windows, which prevent glass from flying out onto the street, which could potentially, hurt people. So many different features. They are just some. There are others which you could have mentioned as well. But any 3 for the and accurately for the level 6. Okay, so another skills-based question here. We've got figure 7 below shows information about several earthquakes. We've got a scatter graph with number of deaths in thousands on here and the strength of the earthquake on the Richter scale. You've just got to complete the table. Easy peasy. Japan, 1995. Let's find Japan. 6.9 on the Richter scale. And the deaths were 6,000. Taiwan, 1999. Let's go to Taiwan. It tells us number of deaths is 3,000 on the Richter scale, 7.7. India, go to it here. You can see that's 7 points. So India, there. So deaths, it tells us are 20,000. India, deaths are 20,000 there. And that is, again, see, that's 5, 6, and 7 on there. And then finally, Pakistan, which is 7.5. And look at that. I think it's about the line. It looks like 70,000. What does the data tell us about the relationship between the strength of an earthquake and its impact? So once you've filled in this table, and you can look at the graph as well, we can see, well, is there any actual correlation? Could we put a best fit line from it? So with increasing strength, is there in fact more deaths? Well, no. There is in some cases. So you look at Pakistan and Iran, they're fairly high on the Richter scale and fairly high numbers of deaths. But then when you look at places like Japan and Taiwan, we can see that high on the Richter scale essentially has caused very low levels of deaths. So in describing that relationship, it's basically saying that and if you applied your knowledge here to really do well to get a level 7, you'd have to link it to the level of economic development. So we could go through that again. Some countries, such as Pakistan and Iran, have high Richter scale measurements and high numbers of deaths. However, it doesn't necessarily mean that a high Richter scale measurement is going to result in a high number of deaths, because it will depend on the level of economic development of the country. That's just one reason, actually. There are other reasons which could contribute to the number of deaths. And that links with this question here. This is where it's good that you've read all the questions one after the other, so you get an indication of what's coming next, so you don't repeat information unnecessarily. Give 4 factors that can cause earthquakes of the same strength to have different impacts. So you could have how earthquake-proof the buildings and the roads, etc. are. So you could have the population density of the area. You could have the focal depth, how deep the focus is underneath the ground. You could have whether the area is more urban, where city areas, city or towns, built up areas, or whether it's a rural area. So there you go. There's 4 or 5 straight away that you could put in there. Okay, and finally, quite a difficult question here, maxed out at level 8. Level of development is the primary reason why impacts of earthquakes vary. Discuss this statement with reference to 2 earthquakes you have studied. So, it's we're looking for a structured answer here. You're looking at the inclusion of case studies. You have actually, you've studied 2 different ones. Hopefully you've had a look at both what you and your partner have done, and you've come up with a conclusion about, what has contributed to the death toll and the damage caused by each of the earthquakes. So essentially you've been asked to do a less economically developed country and a more economically developed country. So you'd have to provide your case study detail. Will obviously depend on what you've done. Maybe you've done Kobe, Japan 1995. You've written about, how much damage was caused in terms of the cost. You might have written about, what the Richter scale was. And it was 7.2 for that one when it occurred, 1995, January. And then you write about how much the death toll was. The death toll, we see different figures between about 5,500 and 6,000, but it's relatively low for a high Richter scale earthquake, which had quite a shallow focus. And so therefore you might be arguing at some point that even though some of the earthquake-proof buildings did collapse, many did survive. The roads did snap like dry twigs for that particular case study, but you might come to the conclusion that a high level of economic development and protectiveness and preparation from the Japanese government, even though it was not very successful in putting out the fires, contributed to a low death toll. However, the cost of it, both short-term and the cost of it was high in billions of dollars due to the damage caused because of the expensive buildings. But then you might want to bring in maybe your long-term effects, thinking about how quickly it took Japan and the Kobe port or whatever to recover from the earthquake, and how quickly the businesses reacted to this and were back up and running. And then you make that comparison with your LEDC earthquake. Whatever you decide to do, it might be that you've picked one of these from here. And you might have looked at the Pakistan 2005 or whatever it is, at a high death toll, and come up with, well, why was it high? What was the focal depth like? What was the actual cost of the damage? Why do you think so many people, why there was such a high death toll? Was it because the buildings were poorly designed, they weren't protected, etc., etc.? And then you come to some conclusion based on that. It's only 2 earthquakes, so it's not like you've got a whole range, but that's the type of thing we're expecting. An application of good case study knowledge with comparisons and going back and answering the question: is it level of economic development the primary reason, or are there other reasons which you feel are also important in contributing to the death and destruction caused by earthquakes? Anyway, I hope that's been useful, and then what you will do after that is try and set yourself some targets in terms of what you could actually do to improve on your examination technique and your geography knowledge and understanding.